Okay, so let's take a look at the solutions to your test. I'm not going to make this video nearly as formal as the other videos because those ones I'll reuse and this one I probably won't reuse. Anyway, so we're going to go ahead and just work through this. You can skip around to whatever you need if depending on what you got right or wrong. I should have told you in a comment which ones that you got incorrect or partially correct or whatever, but you still might want to look through this anyway. So let's go ahead and do this. Start number one, square root 32. The best thing to do is think about how can we factor 32 apart? We want to take the biggest perfect square that's a factor. So 32, I saw a lot of people doing 4 times 8, which is okay, it does simplify, but there's actually a bigger one you can take than 4. It's 16 times 2 is actually the biggest one. So we're going to do this as root 16 times root 2, which is 4 root 2. That's your final, most simplified, okay? Next, root 12 times 5 root, or plus 5 root 3. Root 12 is root 4 times root 3. We've done that one before. Plus 5 root 3. And root 4 is 2. So this is 2 root 3 plus 5 root 3. And so that's going to give me 7 root 3 as my final sum. If you remember one of our conventions, since there's a square root on the bottom, one of the conventions is to not have a square root on the bottom. And we took care of it by multiplying by 1. But we're going to leave 1 in the format of something over itself. And if you remember, we choose the same number as this, because then when we multiply, the square roots cancel out, right? Root 3 times root 3 is 3. So the final of this is 5 root 3 over 3. 2a says square root 24 equals what times root 6? Well, this is kind of giving it away, to be honest, because we know that this is 24 is 4 times 6. So the root of 24 is root 4 times root 6, which is 2 root 6. So you should show those steps there. Some of you wrote this as 2 squared. Underneath, if that helps you remember to cancel it out, that's okay. No problem. And some of you did the same thing here with 16 as writing it as 4 squared. But either way, you should have 2 root 6. So in this case, k equals 2 because we're wondering what number is before the root 6. 2b, root 18 plus k root 2 equals 7 root 2. And root 18, 9 times 2 is the best, and don't forget your square roots, is the only way actually to break this one down. So that becomes 3 root 2. So we get 3 root 2 plus k root 2 equals 7 root 2. And in this case, this is what I'll kind of do number 3 as well here because it's the same problem. And we asked if Kenny did this correct. In fact, it turns out Kenny did do it correct all the way until step 4. Step 4 was his mistake because here, if we notice, Kenny did minus 3 root 2 and minus 3 root 2. And then we get k root 2 equals. And he subtracted the roots off, but we have to think of them we have to think of these like terms, and we don't, that root's not gone. It's like 7 root 2's minus 3 root 2's. How many more root 2's do we have? There's 4 root 2's left after I subtract that. And so you can see here that k must equal 4, right? Now, you may have just been able to know that from here without doing the other steps like he did, which is fine. You could have just said, oh, okay, well, I know k has to be 4 because 3 of these plus 4 of these is going to give me 7 of them. Okay? So we've done actually 1, 2, and 3, and we can look at 4, 5, and 6 together real quick. Number 4, so we're just doing some more calculations here. Negative 2 root 3, whoops, need to write the negative 2, times 11 root 3. And I want you guys to remember that this is all just one big string of multiplying. So we can rearrange anything and put it together. So we can see the negative 2 times 11 and negative 22. One thing that a lot of people accidentally made a mistake on was thinking that there's just one root 3 here. But how many of them are there here? This isn't adding, so it's not distribution. So that you're not like pulling a 1 root 3 out. There's actually 2 factors of root 3 here. So root 3 times root 3 is just 3. And this gives me negative 66. But it's important you showed all your work, okay? I need to see the work that you did to get that. Part B seemed like it was actually a little easier for people. It said just the sum of these things instead. This is where you can think of it as you can almost think of this as distribution. You could think of this as pulling one single square root 3 out and leaving negative 2 plus 11, and this is 9, and I get 9 root 3. But you can also just see this and say negative 2 root 3s plus 11 root 3s gives me 9 root 3s. Technically it is distribution though. And then lastly, it's the same thing. Negative 2 root 3 minus 11 root 3. Don't forget the negatives. And when you subtract it, you get negative 13 root 3. Okay? So there's number 4. Let's go ahead and do numbers 5 and 6 and call it good. Let me check my phone. Good, it's still working. It's been getting full, and it cut me off the other day. Let's look at the last bit, and then we'll be done for the day. Okay, so number 5, Monathan Gendoza wants to build a fenced-in area for his ducks in the shape of a square. So for 5A, to be honest with you guys, really, probably the easiest way to even explain it is to actually draw the diagram. If I have a square with side length x, then literally the area of it is x times x. And since we're given that that's 70, x squared equals 70. You could have put that in words, but I mean, that's basically the way to explain it. And then estimate the length of x. Now listen, x squared equals 70. I saw a lot of people use the calculator on this because there's no way you could have gotten that close by just, guessing or whatever. This was a no calculator test, and I think some people missed that. But if you just want to estimate, okay, well, what squared equals 70? Is there something close? Yeah, I think 8 squared. 8 squared is 64. So it seems like it should be something a little bigger than 8. And honestly, my guess, I don't know it off the top of my head what this is. A lot of you realize this is the square root of 70, which totally great. My guess is like 8.2 or 8.3, because 81 is the next one. So let's just guess 8.3. And I'll check it right now. Square root 70. Well, I was pretty close, 8.36. So about 8.4 or so. But we can leave it like that. And then C says estimate, or how much fencing does he need approximately? Well, I mean, there's 4 sides, so you just, whatever you get from your estimate there, you can just multiply it by 4, right? Some of you wrote 4 root 70, and that's the exact correct answer. But you could also put 4 times whatever your estimate was. As long as your estimate was close to 8.3, then you get that correct. And this gives me, let's see, 32 plus 1.2, so 33.2 would be my estimate. Okay. Last one, number 6. We've got a bunch of numbers here. And we want to know if they're rational or irrational. Okay, it's going to be helpful to remember that video that we watched last week. In fact, it's going to be really important to remember that. Hopefully maybe you remember some patterns for like the repeating decimals like this last one. But let's just go through. Rational? Yes. Do I need to write it in fraction form? No, it's already in that form. We already know this one is irrational. This one may seem confusing at first, but look, there's a pi and a pi here and here that are factors. So those can actually cancel out to 1. So negative 2 over 6 actually is equivalent to that original thing, okay? Now you could of course call this negative 1 over 3, but either way it still fits the definition, remember, of a rational number. Integers on top and bottom. Root 7, we've learned that if it can't simplify the root, that it's going to be irrational. This right here is a yes as well, but you needed to actually finish it and write it as fraction form. And 218 over 100, which if you want, you could divide, I think, by 2 and get 109 over 50 if you want. And then this one here, if you go through all the steps, you're going to get 38 over 99. Maybe you've already memorized that pattern, but if you go through the steps that we did in the video, you can see that yourself later or ask me maybe. But let's call that good. You can check your own work yourself, and then if you need to do a retake or something, connect with me as soon as possible.